Welcome everybody. It's Ramchandra from CIVIL-MECH-MATHS Concepts. It is the 20th lecture on structural analysis. I have discussed many topics on structural analysis, and for the last 3 lectures I have been dealing with maximum deflection and deflection in various beams and under various loadings. We had already discussed about the deflection in cantilever beam with point load applied at the free end and deflection due to application of the moment. Application of moment is one of the important topics which requires a more attention because more number of questions being asked on the application of moments. When I have written my examination, I was asked to find out the deflection because of the uniform distributed load, not because of the uniform distributed load, because of the uniform movement. That means movement is applied uniformly over the length of the beam. Hence I thought it is prudent from my side to provide you with more examples on the application of movements to the beams, in addition to the application of point loads and uniformly distributed loads, triangular shaped loads. Now, we have already discussed about the application of moment in cantilever beam. Today we will discuss about the application of moment in a simply supported beam. We have to find out the maximum deflection. Maximum deflection is not at the center. It will be somewhere at a distance x from the left hand side. That x we have to find out. Once the position of the maximum deflection is found out, from that we can find out the maximum deflection in the simply supported beam. Delta max is equal to ml square by 9 root 3 EI for this particular loading. A simply supported beam of length L is subjected to a moment M at one of the left hand side supports. And I am Ramchandra from CIVIL-MECH-MATHS Concepts, and I will be giving typical examples to you. With the examples I will be explaining the concepts to you. And whenever the concepts being explained to you, please refer to my lecture. Please refer to my old lectures also, where I give the reference to the objective type questions can be asked either in UPSC Engineering Services examination or in the GATE examination or in the Staff Selection Commission JE examination. That explanation and understanding the concept is more important rather than the numericals. I give more importance to the concepts. Let us delve into the concept of this. Application of moment, what does it mean in case of a simply supported beam, and why this particular deflection is not at the center but rather at a distance x from the center, and we are going to find out that x, and how to calculate the reaction forces when movement is applied. When forces are applied, point load or UDL, we can say sigma fx is equal to 0, sigma fi is equal to 0. But when movement is applied, what to do? There are no horizontal forces, there are no vertical forces, literally. Sigma fx is equal to 0, sigma fi is equal to 0. There are no vertical downward forces, external forces. Then how to calculate the reaction forces? There are no external forces are absent except for movement. Then how to calculate the reaction forces? That is one of the topics we will be dealing now. And If you feel that my videos are adding some value to your knowledge, please subscribe to my channel for regular updates, and also it will encourage for me to delve into more and more depth of the subject and give you more and more knowledge. Knowledge sharing, I will be doing it. Definitely I will be doing it. But a little bit of encouragement will be given to me if you comment for improvement and if you subscribe to my channel, so that I will delve into the subject further and further, and I will provide more and more lectures for you. But still, even though there is no subscription, it's not compulsory, it's up to you. I will provide the best possible lectures for you. We'll delve into the subject. Let's go ahead. Now what is given is that a simply supported beam is there. It is subjected to a moment like this M. As I told you already, there are no external vertical forces. Hence, sigma Fi is equal to 0 implies Ra plus Rb is equal to 0. Please try to understand this. Ra plus Rb is equal to 0. And at the end B, moment is 0. At the end A, moment applied is equal to M. Now, we have to find out Ra and Rb. With this, I will draw the bending moment diagram. It will be like this. 0 at B. B, it is 0. And it increases up to A linearly. Here it is M. This is A. This is B. Are you able to understand here? For a simply supported beam, that supports, the bending moment is 0. Now, we'll try to calculate the reaction forces. How to calculate the reaction forces? Sigma Fi is equal to 0, Ra plus Rb is equal to 0. That is one equation we have got. And we will take moments about point A. Taking moment about A. What happens? Rb is acting as per our assumption, it is acting like this. That means Rb towards A, it will be acting like this. Due to Rb, moment is in this direction for the length L. Okay, and there is no other movement. That moment, another moment, external moment is M, it is acting in this direction. At RB, because of the direction of the force, we have assumed, this is the assumed position. This is the assumed position. For this, the moment is acting like this. Here, RB moment is acting like this. What is that moment? Moment is RB into length or RB into X. RB into L is the moment RB into X. When X is equal to L, what is the other moment acting? Another moment is acting, external moment is M in this direction. Both are in the same direction. This is M. This is RB into L. That means M plus RB into L is equal to 0. For a system to be under equilibrium, static equilibrium, total moment should be 0 at a particular point. Now you just see. M plus RB into L is equal to 0. M is the external plus RB is not known is equal to 0. That means RB is equal to minus M by L. This is the value what we have got. Reaction. That means reaction is not upwards, reaction is downwards. Now, the given beam what happens? RB is acting this way, M by L. When we have given the downward direction, we should not put the negative, because direction itself is negative. And this is RA and this is M. For this combination, RA plus RB is equal to 0. We have already seen. From here, sigma Fy is equal to 0, RA plus RB is equal to 0. That means RA is equal to minus RB. That RA is equal to minus of minus M by L. That is M by L. This RA will be M by L. Please be very careful in directions. If you put the direction, don't put the negative sign. If you have put the direction, then you put the negative or positive sign. If you say this is minus M by L, then this should be M by L. Okay? Don't mix up both. Either it should be upwards minus M by L or downwards M by L. Now, these are the reaction forces. This is what we have got. Shear force diagram, how it will look like. What is the shear force diagram? Convention sign. If a block is like this is positive. And for this, right hand side upwards, I have told many times in my previous lectures. Right hand side upwards and left hand side downwards is positive. This is a shear force diagram. This value is M by L. This is SFD. We have drawn the SFD. Why I am going slow and explaining this? Because dealing with moments is very tough task. With loads you can very easily do it, but with moments we should be very careful about the sign, convention, and also about the moments, how they are acting. Now, we have to draw the bending moment diagram. For BMD, what is that beam forces? This is M by L. This is M by L downwards, and the length is L. and there is a movement here in the anti-clockwise direction. Please see everything very carefully. With reaction, the movement will be like this and like this. With this reaction, the movement will be like this and like this. This is minus. External is this way. Now you tell me, what is the sign convention to be followed? Please give a thought. Whenever you are confused with the sign convention, I give one trick. Go with algebraic equation. Take moment at a distance x from the point under consideration. Mx is equal to, what is reaction Ra? It is going this way. That means clockwise direction. And what is the applied moment? This is due to Ra at x, at point x. Let us say this is the point x. When you consider at point x, this is the point x. When you consider at the point x, m by L is causing a movement in this direction. Whereas applied movement is in this direction. Both are in opposite directions. When reaction causes the direction in this direction, this is positive. This m by L is causing a positive movement. Whereas whatever the applied moment is causing a negative, opposite direction. Hence, we can say, what is the net effect? One is, one movement, m by L movement is this way, and it is external. Don't be confused with the member movement. It's not a member movement, it's an external movement. It's external. It's not member movement. M by L is causing this way and external is causing this way. M by L, when it is causing this way, we say it is a positive convention. And external is causing this way, it is going against the reaction. Against the reaction means minus, it should be deducted. The effect should be deducted. That means from m by L into x, what is the effect to be deducted? M should be deducted. What it will be? When x is equal to 0, m by L into 0 minus m, that is equal to minus m. That means when you apply an external load this way, this is negative. That means the value of the bending moment what I am getting is negative. When at x is equal to 0, my bending moment is minus m. Then what will be the bending moment diagram? It will be 0 as usual at the support end for a simply supported beam, and it's like a triangle. This is m, this is minus. Now we have got shear force diagram and bending moment diagram. What is a beam? Because why I am giving shear force bending moment diagram? In the examination, they may not ask deflection also. They can ask anything. When something is, a moment is applied, M by L, this is M by L. They can ask reactions also, show the reactions. They give the alternatives. Like both M by L, they will keep on the upward direction. Both M by L, they keep in the downward direction. They keep right hand side in the upward direction, left hand side in the downward direction, something like that they give. And the M by L on the left hand side should be upward direction as per the convention what we are following from the beginning. And M by L for the movement of a member, if it is a member, then this is positive. This is what convention we have followed. External movement is applied means to this it is opposite, this can be minus. External. This is the convention we are following. Please follow the convention. And in the objective type they can say the reaction at the left hand side and right hand side both are in the same direction. Both are in opposite direction. Direction cannot be found out. And it depends upon the cross section of the material property and cross section of the beam concerned. No. Only one answer is correct. That is, the reactions are in the opposite direction. When this is the loading position. This is the length. And SFD is positive with M by L, positive. SFD is a rectangle. They may ask even the question, SFD is a rectangle, triangle, or it's a curved. It should be a rectangle. And BMD. What is the BMD? BMD is sign opposite to the SFD. This is SFD, this is BMD, and BMD is a triangle. This is what is the SFD and BMD. Now once we have SFD and BMD, we can find out the deflection using the double integration method. Using the double integration method, we can find out the deflection. Using double integration method, we will find out the deflection. Then we will go for the maximum deflection. Deflection general equation we will find out. Then position of the maximum deflection we will find out. Then we will go to the maximum deflection. Now in this, you have to make a note of these things. When something is pinned, pin joint, slope, something is pin jointed, slope is, it's a very important concept I am telling you. There can be questions on this. In a pin jointed support, slope is not equal to 0, but deflection is equal to 0. Slope means we can say angle, theta. Theta is not equal to 0. But deflection is equal to 0. In a roller support, theta is not equal to 0, delta is equal to 0. Angle, rotation angle. When rotation angle is not equal to 0 means tan theta is the slope. In a fixed support, angle of rotation is 0 and deflection is equal to 0. Very, very, very important. Please make a note of it. A question can be asked, and principle of superposition uses these principles. At a pinned joint, the angle of rotation is not equal to 0. Rotation is possible, but deflection is not possible. Deflection is equal to 0. In roller support, rotation is possible, but deflection is not possible. Deflection is equal to 0. But a fixed support, rotation is also not possible and deflection is also not possible. For this, theta is a fixed support, theta is equal to 0 and delta is equal to 0. For a pinned support, theta is not equal to 0 but delta is equal to 0. There can be rotation, but deflection may not be there. For a roller support also, theta is not equal to 0 but delta is equal to 0. Please remember this. Any question can be asked in the SSC examination or GATE examination or engineering services examination. A question can be asked, match the following. They will reverse. Pinned, delta is equal to 0, theta is equal to 0. Roller, they may confuse you. Please don't get confused. Please remember this. It's very much required for a structural engineer. And what are the boundary conditions? From the above, we can derive the boundary conditions as A is pinned. Pinned support means theta is not equal to 0 but delta is equal to 0. That means delta is equal to 0 at x is equal to 0. That is one boundary condition. Second boundary condition, support B is roller. At roller, theta is not equal to 0 but delta is equal to 0. That implies delta is equal to 0 at x is equal to L. For the length. Whatever may be the external loading, these are the pin joint properties. Pin joint, fixed joint and roller joint. These are support, rather not joint, rather support. Pinned support, roller support and fixed support, they are the properties. Those properties will not be changed by the application of the load. Let it be movement, let it be vertical force, horizontal force, any force, these properties will not change. Now we have got the bending moment diagram and then our shear force diagram. Now, using the double integral, we have to go for the calculations using these BCs. What is our beam theory equation? This is one of the favorite topics. We are doing it for the last 10 lectures maybe. As per beam theory, M by I is equal to sigma by Y is equal to E by R. Implies M is equal to EI divided by R. That implies this equation gives a generalized equation for us in the form of differential equation. EI into d square delta x by dx square is equal to mx. When x is taken from the support A, from the left hand side support A, then what will be mx? Mx is equal to, what is mx? M by L is the reaction force that is acting in the clockwise direction. This is acting this way, M by L. Mx is equal to M by L into x minus M, because this is like this. External is opposite to the internal member movement. This M by L is the reaction force at A. This is acting this way when x is here, and M is acting in the opposite direction, that is minus M. This should be positive. For a internal members we have seen this is positive, whereas for external it is negative. External. Now M by L x minus M. Now this is from 0 less than or equal to x less than or equal to L. This can be written as mx is equal to m into x by L minus 1. That means EI into d square delta x by dx square is equal to m into, this is the external load, that is the constant given to us, x is not known to us. Now by integrating once integration yields EI into d delta x by dx is equal to m into x by L, that means x square by 2L when integrated, minus x plus C1. Do you agree? In once integration, here this is nothing but theta. Now second integration is EI into delta x is equal to m into x cube by 6L minus x square by 2 plus C1x plus C2. C1, C2 are the integration constants. Now, with this, we know the boundary conditions. At A, x is equal to 0 and delta is equal to 0. At the pinned joints, delta is equal to 0. Pinned support, delta is equal to 0. Pin support. That means m into 0 cube by 6L minus 0 square by 2 plus C1 into 0 plus C2 is equal to 0. That implies C2 is equal to 0. Next boundary condition, applying BCs. Second boundary condition is at B, x is equal to L, delta is equal to 0. That means m into L cube by 6L minus L square by 2 plus C1 into L is equal to 0. C2 is already 0, we have found already. That implies M into L cube by 6L, that means L square by 6 minus L square by 2 plus C1L is equal to 0. That implies L we can take out. C1L is equal to M into L square by 2 minus L square by 6. That is equal to ML square into 1 by 2 minus 1 by 6. That implies when you cut L on both sides, it will result in C1 is equal to ML into 1 by 2 minus 1 by 6. That is equal to ML into 6, you can take common factor. 3 minus 1 is 2, 2 by 6, that is 1 by 3. That is equal to ML by 3. Now, the final deflection equation is, will be EI delta X is equal to M into X cube by 6L minus X square by 2 plus MLX by 3. That implies for finding maximum deflection, the above deflection equation to be differentiated and value to be made equal to 0. That means d by dx of EI delta x is equal to 0 for maximum delta x value. That implies d by dx of mx cube by 6L. d by dx of m into x cube by 6L minus x square by 2 plus mlx by 3 should be equal to 0. That implies m will get cancelled. 3x square by 6L 3x square by 6L minus 2x by 2 plus L by 3 is equal to 0. That means 3x square minus, when you take out all this 6L you can take as the denominator, and when you take 6L as the denominator it will be 3x square minus 3L into 2x plus 6L is the denominator, L into 2L is equal to 0. That means 3x square minus 6xl plus 2l square is equal to 0. That is 3x square minus 6lx plus 2l square is equal to 0. By using the general x value solution, it's a quadratic equation, minus b plus or minus square root of b square minus 4ac by 2a principle, it will be minus b is plus 6l plus or minus square root of b square means 6l whole square, that is 36l square, minus 4a means 4 into 3 into c is 2 whole divided by 2 into 3. Therefore, x is equal to 6l plus or minus square root of 4ac 2l square 24 36l square minus 24l square whole divided by 6, that is equal to L plus or minus 36 minus 24 is 12 square root of 12l square by 6. When it goes into the square root, it will become 36. That implies x is equal to L plus or minus L by root 3. That is equal to, that implies x is equal to L into 1 plus or minus 1 by root 3. Because the x cannot be more than the length of the beam, we cannot take a plus sign, and it should be less than the length of the beam. We should take x is equal to L into 1 minus 1 by root 3. What is 1 by root 3? By the by, please see. One minus 1 divided by root 3, that is 0.422 L. That means at a distance of 0.422 L or 0.423 L, the deflection is maximum. Not at the center, please see, not at the application of the load, even though which we have seen, application of the load here, application of the moment, not at the place where moment is applied, not at the place center of the beam. It is at a distance of 0.422. The deflection will be like this, deflection, it will be like this. This is at a distance of 0.422 L. And what is the quantity of this deflection? It is at a distance of 1 minus 1 by root 3. Either you call it as L into 1 minus 1 by root 3. Either you call it as 0.422 or L into 1 minus 1 by root 3. This is the x. This is the maximum deflection, that is delta max. Now you calculate the delta max. You know the x. Delta max is equal to, what is the equation we have got? EI delta max, we have got an equation 1 by EI into m into x cube by 6L, 1 by EI into m into x cube by 6L minus x square by 2 plus mlx by 3. X is equal to L into 1 minus 1 by root 3. This you apply in the above equation. And you will get the value as delta max is equal to ml square by 9 root 3 EI. This is what is given. This is what we have to prove. We have proved. This whatever substitution of x in this equation and getting the value, that you do it as a homework. Simple algebraic equations, you please do it as a homework. 1 minus 1 by root 3 you can put, or 0.422 you can put. Let us try to put 0.422. 0.422 cube divided by 6 minus x square by 2 means 0.422 plus x by 3 means 0.422 divided by 3. This value tallies. You please remember this value, and the takeaways from this lecture I will explain you for 2 minutes. What are the takeaways? 1. The maximum deflection is not at center of SSB for the given moment application, external moment application. 2. The maximum deflection is at 0.422 L from left hand side. Third takeaway, the bending moment diagram is equal to negative as per the conventions which we have used, is a triangle, and SFD is positive rectangle. These are the takeaways from this lecture, and as I told you few minutes back, what type of questions can be asked. This is one of the most important observations from the simply supported beam when subjected to a particular moment. If it is subjected to a uniform moment, UML also, you can find out. Instead of UDL, you take it as a UML. M is your load. Load need not be point load. Load need not be any UDL. Load can be UML also. Uniform moment, or load can be a single moment also. This is a very important derivations we made in this lecture. Best of luck to everybody. Thank you for listening to me. And please remember whatever the takeaways I have given to you and whatever the observations I told you, during the course of our interaction, this particular deflection on the simply supported beams is and cantilevers is very very important. Please pay attention to it. In one of the engineering services examinations, the question is given on simply supported beam with a overhang, that you please try in home, but if you can do it, there is a length L and a overhang of overhang of L by 2. There is a point load P here and it's a simply supported beam. Find the maximum, not maximum actually, what they have asked is find the deflection at free end of the overhang. Please try it. If you cannot do it, I will do it in the next class. And many people have done it wrongly, I know. And some people thought that the alternative is not given in the exam, in the examination question paper. That's wrong. And we will get the question correctly and the answer also correctly. Everything in examinations like GATE, staff selection, I feel there will be very minimum errors, and we should not strive for finding the errors, we should strive for finding the solution. Best of luck to everybody. It's Ramchandra from CIVIL-MECH-MATHS concepts. If any value addition is done due to this lecture to you, please subscribe to my channel CIVIL-MECH-MATHS concepts. I will be giving this type of problems to you and clearing the concepts on regular basis, and I have a playlist for GATE Civil Engineering by IITN, and another playlist is also there, SSC JE Civil Engineering by IITN. These links of the links of the playlists will be given in the description or given in the description. You can use them to reach out to my all videos. There are around 61 videos I think are published from my side. Please see them, view them, comment and review them. Thank you. Best of luck in your examination. Thank you for listening to me. Thank you for seeing my lecture.